good look at this question. This question we are asked, which of the following species act as a Lewis acid? Which among the following acts as a Lewis acid? Now, as a cause of this explaining Lewis acid, I'm going to explain the different scientists that contribute to the definition of acid. Now, we have about 3 scientists. That is, we have Vance Arrhenius, we have Arrhenius, we have Bronsted and Lowry. Bronsted and Lowry, there are 2 different scientists that, and we have Bronsted. They combine together to define what an acid. And another one we have Lewis. So these are the various scientists that contribute to the definition of what of an acid. Now we're going to look at the various scientists, how they define an acid. According to Arrhenius, defined an acid as a substance that, when dissolved in water or in aqueous solution, it produces an hydrogen ion. A substance that produces an hydrogen ion in aqueous solution, or you say acid is a substance that, when dissolved in water, produces an hydrogen ion. Do you get that? For instance, we have HCl. In aqueous means that it must be what? In water. It produces what? Hydrogen ion plus what? Cl. So a substance which, when in aqueous solution, when dissolved in water, produces an hydrogen ion is what we call what? An acid, according to Arrhenius. So this one now is what? An acid, because of what? It produces an hydrogen ion. Alright. Another example is H2SO4. In aqueous produces what? SO4 minus. So it produces what? 2 atoms of what? Of hydrogen ion. Do you get that? So because it produces hydrogen ion when dissolved in water or in aqueous solution, this substance is what? Is an acid. This one is traced to what? Straight to Arrhenius. Do you understand? Now Bronsted-Lowry define an acid as a substance that donates a proton. A substance that donates what? A proton to another substance. That is what we call an acid. It must not be an aqueous solution. Now Bronsted-Lowry, now example of Bronsted-Lowry acid, HCl plus H2O will give you what? Will give you H3O plus what? Cl minus. Look at this, is what? A Bronsted-Lowry acid. This one now, look at this one now, donates proton to this one now. Do you get that? So it donates hydrogen to water to form what? Hydronium ion. So this one now is acting as what? As an acid. Do you understand? So another example is we have NH2. We give what? NH3 plus H3O plus. This is another example of what? Of Bronsted-Lowry acid. So this one now, look at this one, donates a proton to this one now to form a hydronium ion. So this one now, ammonium ion now, is now acting as what? As an acid, because of what? It donates a proton. Do you understand? So this one is a Bronsted-Lowry what? Definition of what? Of acid. Now let's look at this one. Among all this one that I just mentioned, we have not gotten the answer yet. Now let's look at Lewis acid. All right. In Lewis define acid that acid is a substance that accepts a pair of electrons. A substance that accepts a pair of electrons is an acid. For instance, now we have boron trifluoride plus ammonia will give you it give you something like fluoride ammonia. Now what this means is that ammonia here donates. Remember, ammonia has a pair of electrons. Look at the structure of ammonia here. So ammonia has what? A pair of electrons. Boron on the other hand now needs a pair of electrons. Boron on the other hand, look at boron here. Yeah? Boron trifluoride. Now, this one now will donate this pair of electrons and give to what? And give to boron. So two of them will now form a coordinate dative bonding. Do you understand? So that is how it is now. So this one now that accept, the one that will accept, look at this one will donate. So this one is that donate is serving as what? As a base. I don't know why this one that accepts a pair of electrons is an acid and ammonia. So our answer about this one now, look at this one is acting as a base. Why this one that accepts a pair of electrons is acting as what? As an acid. So our answer is what? Another example is aluminum trifluoride plus chloride ion will give you what? Aluminum tetra.